Now let's look at complex conjugates. If we have a complex number, z equals 8 plus 2i, then the complex conjugate is just going to be the opposite sign to the imaginary part. So if z equals 8 plus 2i, then z star, or the complex conjugate, is going to be 8 minus 2i. Okay? Same thing for part B. Z is equal to 6 minus 5i. Well, then z star is going to be 6 plus 5i. Okay? We're always flipping the sign of the imaginary part. And the reason why we can do this is because, let's say, we have z here. So z is equal to 6 minus 3i. Then z star is going to be 6 plus 3i. Okay? We can work out the addition and the multiplication of the conjugate and the complex number, and it should cancel out the imaginary part. So z plus z star is going to be 6 minus 3i plus 6 plus 3i, yeah? Which is the same as 12, 3 minus 3 is 0, so it's just 12. Z times z star, that's just going to be 6 plus 3i and 6 minus 3i. Oh look, that's a difference of 2 squares. So that's just going to be 36 minus 9. Okay? Which is the same as 45. So that's the main use of a complex conjugate. Let's take a look at this one though. Z is equal to 10 plus 5i, which means that z star is going to be 10 minus 5i. Z plus z star is going to be 10 plus 10 plus 5i minus 5i, which is just equal to 20. Z times z star is just going to be 10 plus 5i, 10 minus 5i, which is the same as 100 minus 25, which is the same as 125. Do you understand? So the whole point is we are eliminating the complex conjugate. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Let's use that to help us with this question. Write this complex number in the form x plus iy, where x, y are real numbers. So, first thing we're going to do is we're going to rewrite the fraction. So 3 minus 4i all squared over 1 plus i. And we're going to times both top and bottom by the complex conjugate of the denominator. So this is timesing 1 minus i over 1 minus i. Why? Because that's just going to be the same as 3 minus 4i all squared times 1 minus i all over 1 squared minus 1 squared, which is the same as 3 minus 4i all squared times 1 minus i over 2, okay? Now we can expand that top part. If you want to, you can expand the top part first. I just chose not to. So, that's the same as r half times 3 squared minus 2 times 3 times 4i plus 4i squared times 1 minus i, which is the same as r half times 9 minus 16 is minus 7. And then 2 times 3 times 4 is 24. So minus 7 minus 24i. Okay? Now let's take a look at that when we expand it to 1 minus I. That's just going to be a half times minus 7 plus 7i minus 24i plus 24i squared. Okay, so a lot of negative numbers, no big deal. Minus 7 minus 24 is 31 minus 31. Okay, and then 7 minus 24 is equal to 17. Sorry, minus 17i. And then do half of that, we should get minus 31 over 2 minus 17 over 2i. Okay? So all we're doing, it's kind of like we're rationalizing the denominator. Okay? Alright. Do you need more help? Well, you can join my Discord server and ask me whatever questions you want down below. Now let's look at this last example. Here we have a complex number given as z equals p plus 5i over p minus 2i. The real part of z is a half. So how are we going to work out what p is? Well, if the real part of that is a half, then z is equal to a half plus yi. Okay? So now what we can do is we can, again, rewrite this so that it's all in one line and then compare the coefficients. So p plus 5i over p minus 2i. We're going to first find the complex conjugate of that, which is just going to be p plus 5i, plus 5i, excuse me, p plus 2i. Why? Because again, all we're doing is changing the sign of that, aren't we? And then times them together. So we've got p plus 5i, p plus 2i over p squared minus, p squared plus 4, if anything. And then we can expand the top to give us p squared plus 2pi plus 5pi minus 10 all over p squared plus 4. Okay. So how can we use that to help us? Well, we can then split the fraction apart. So that's the same as, if I actually write that here, that's the same as p squared minus 10 over p squared plus 4, right? Plus 7pi over p squared plus 4. That's the same as a half plus yi. We don't know what y is, but we also don't care what y is, because we know the real part is a half, okay? So therefore, we can work out what p is from here. We can solve this equation. So, p squared minus 10 over p squared plus 4 is equal to a half, which means that 2p squared minus 10, if we cross multiply that, is equal to p squared plus 4, which means that 2p squared minus 20 is equal to p squared plus 4. Put it all to one side to make it equal to 0. P squared minus 24 is equal to 0. Put that in my bracket, so p plus root 24. p minus root 24 is going to equal 0. So we know that p is equal to plus minus root 24. But we know that p is greater than 0. So p is actually just plus 24. Okay. So now, how are we going to work out what z is? What we can do is we can, if we want to, plug it into our calculators. So we know that the complex part, the imaginary part, excuse me, is going to be 7 root 24 over 24 plus 4. Okay, which is also equal to 7 root 24. Root 24 is the same as 2 root 6. Okay, so there's actually 14 root 6 over 28, which is equal to root 6 over 2. So therefore, and I'll plug this in, right, z is equal to a half plus root 6 over 2. I'll put it up here again in case you can't see. Yeah? Why? Because all we're doing is comparing the like terms and we're using the complex conjugate. Thank you guys very much for watching. Do drop me an email if you want to get tutored by me and pass your exams. Keep on learning as you have no idea what you're capable of doing.